Hello everyone, this one is the previous year paper, January 2020 paper, and in this video I'll be discussing how to solve the questions asked in this paper. Okay, so let's begin. The first question is about Laplace transform, and let's see how to solve the first question. In the first question we are asked to find the Laplace transform of this given function, and we don't have any standard formula for this type of question, so what we'll be doing is we'll be separating it in two parts. First, the denominator will be taken up and this square will be taken inside. Okay, so we will have this e power minus 4t multiplied with this term. Now on expansion of this term we will obtain this, and separately we will find the Laplace transform of each of these terms. Now there is a shifting rule in which what we will do is we'll first find the Laplace transform of each of these terms and then make s as s minus a. Okay, and a is e power minus 4t, this minus 4 is a. Okay, so when we will find the Laplace transform of 16t square, we will get this. Okay, and instead of s we have to write s minus a, so a is minus 4, right? So s minus a will be s plus 4. So instead of s we will substitute as s plus 4. Wherever we have s here, there all places we will substitute as s plus 4. Okay, and this is the final answer. The next question is a bit hard, so please pay more attention for this one. In this question we have to find the Laplace transform of sine 2t by root t whole power 2. Okay, for this term we don't have any standard formula, so what we'll be doing is we'll be taking the square inside, so we'll be remaining with sine square 2t and t. Okay, now the rule is if we have to find the Laplace transform of f of t by t, that's equal to integral s to infinity f of s ds. Now what is f of s? F of s is nothing but Laplace transform of this numerator sine square 2t. So f of s is equal to Laplace transform of sine square 2t. Sine square 2t can be written as 1 minus cos 4t by 2. Okay, and separating it both we will get 1 by s and s by s square plus 4. By separating 1 and cos 4t, 1 by 2 we can take outside. Now since we got f of s, we will substitute that in this integral formula. Now we have to integrate this part. Okay, now this one is easy, this is log s, right? Coming to this term we have to find some substitution and then we can find the Laplace transform. Okay, now consider this term here, s by s square plus 4 square. Take the denominator as x. Okay, and then differentiating both sides we get 2s ds is equal to dx. Now this can be written as half, and I multiplied the 2 in the numerator and denominator, so I'll have in the numerator 2s ds for this substitution. Okay, so instead of this I'll substitute as dx and s square plus 4 square as x. Okay, so we'll be having this term half dx by x. Now we can find that integral very easily, that is nothing but half into log x. Now we will resubstitute back what we had replaced for x, which is s square plus 4 square, and then it's all just simplification. See, observe here, if I take this half inside this log, okay, it will be, if it's half log a, that's equivalent to log of a raised to 1 by 2. Okay, so when taking 1 by 2 inside we will have root of s square plus 4 square. Now this the other rule which is being applied here is log a minus log b, which is log a by b, so log a by b. Okay, and then what we will do is we will take s square as common from the denominator, so we will be remaining with 4 square by s square in the denominator, and s will get cancelled here, so we will get log 1 when we substitute s as infinity. Okay, log 1 is nothing but 0, so for the upper limit we got 0 here, for the lower limit we will get this same term. Okay, so here I will substitute as 0, so I will get this answer here, and that's just final answer. You can just stop here also, or if you want to take this minus inside and write it in this form, that's also fine. The next question is to find the Laplace transform of t cos at. Let's see how to do that. In t cos at, the formula of finding the Laplace transform is, if t is getting multiplied with a function which is cos at, then the answer is the differentiation of f of s. So let's find f of s. F of t is given as cos at, so f of s is nothing but Laplace transform of cos at. Laplace transform of cos at is s by s square plus a square. Now we will be substituting that in this differential equation. Okay, then after differentiating we will get the final answer. Okay, in the second question we have two parts here. First, the function is given and we have to show that this 1 by s tan h as by 2, that's the square wave function's answer. Okay, that we have to prove. First, let's see here. You have to note down what is the period 2a, and f of t is 1 in 0 to a and minus 1 in a to 2a. Okay, so the standard formula you have to remember, this is the standard formula. L of f of t is this one. Okay, and instead of capital T will substitute the period which is 2a, and now f of t was defined as 1 in 0 to a and minus 1 in a to 2a. Okay, so what we will be doing is, see here, e power minus st will be the same, and from 0 to a we will substitute f of t as 1, and in the next one from a to 2a, instead of f of t we will write as minus 1. Okay, and then it's the simplification one, and after reaching this point you have to make a small modification. Okay, see here, the numerator you will get in this form. Okay, now this form can be written as 1 minus e power minus as whole square. Okay, that's the expansion of 1 minus e power minus as whole square. Okay, this is the expansion. Now the denominator is of the form a square minus b square, that's nothing but a plus b into a minus b, right? So what is a here? It's 1, and b is e power minus as. So if we square it, it will be e power minus 2as. So 1 plus e power minus as into 1 minus e power minus as. Now this one term will get cancelled with this square, and then we'll have these two terms. And now what we have to do, you have to know the formula of tan hx. Okay, tan hx, that formula we'll substitute that here in the powers of e, and this square can be taken. See here, observe here carefully, e power minus as. Okay, that can be written as e power minus 2 into as by 2, right? Because in the tan hx formula we have this square here. Okay, so in that way if we write 2 into as by 2, we'll get 1 by s tan h as by 2. Okay, that's the answer. In the next question we have been asked to find the Laplace transform to find the solution to the differential equation, and these two conditions are given. So this is the function given, and we can write this as y double dash, this as y dash, and we can take the Laplace transform on both sides, and for each of these, see, y double dash and y dash each has an formula. Okay, if we take Laplace transform we'll have this formula. This is for L of y double dash, and this one is for, this whole is for L Laplace transform of y dash. Okay, and Laplace transform of 0 is 0, and then when we take L of y as common from this term, we will be remaining with this, and substituting the given conditions, this one, these two conditions were given to us, substituting that in this equation we will get this, and shifting it here and taking this in the denominator, we will be remaining with 3 into s minus 1. Now the task is very simple, we have to just take the Laplace transform of 3 by s minus 1. Okay, that's nothing but e power 3 into e power t. Okay, that's your final answer. In this question we have been asked to find the Laplace transform of each of these, and let's see one by one. The question given is to find the Laplace transform of this, and what we can do is separate each of these terms and then find the Laplace transform of each of these. Okay, that's direct, by using the direct formula we can do it. Okay, In the second question, we have to do a substitution by using a formula. See, in this question, this is f of s. Okay, we have to find the Laplace transform of f of s. Okay, now we can't directly find the Laplace transform because it's of the form, it's not in the standard form. Okay, so what we can do is first write f of s as cot inverse of s by 2 and then find f dash of s. Why are we finding f dash of s? It's because the formula which we have is Laplace transform of f of t is minus f dash of s. Okay, now if we get f dash of s, and we can take this remaining terms on this side to get f of t. Okay, so that's what we are doing here. First step is to find, to get f of t we need f dash of s. So first we'll write f of s and differentiate it to get f dash of s, and after getting that we'll find the Laplace transform of f of s. Okay, when we get Laplace transform of f of s, we have to write in the denominator divided by t. Okay, so f of t will be minus 1 by t into minus sin at. Okay, that's your final answer. To solve the next question, we have to use the partial fraction method. See, remember, if you get the question in this form where you have in denominator two terms getting multiplied, you have to use the partial fraction method. In this method, we will be separating the denominators and finding what is a and b. After we get a and b, we will substitute back a and b and find the Laplace transform of each of these separately. Okay. In the next question, we have been asked to find the inverse Laplace transform of this function using convolution theorem. Okay. In convolution theorem, we are separating this term into two parts, f of s and g of s. Then we find the Laplace transform of each of these. Okay, so we'll get f of t and g of t. After getting f of t and g of t, we'll be writing this formula, and instead of f of t, we'll write f of u and g of t minus u. So we'll be writing that and finding the integral. Separate the terms. It was sin t minus u. Okay, sin t minus u, separate it, and the constant here is t, so sin t will be constant here and cos t will be constant here. Separate both of these and find the integral. Okay, then substitute the limits to get the final answer. We have been asked to find the Laplace transform by using unit step function method. Okay, in this method we'll have 2 or 3 terms and there's a formula for it, and by using that formula we will find the answer. It will be very easy if we write what is f1, f2, f3 and what is a and b. After observing the question, you should know this is a and this is b and this is f1, f2 and f3. Note it down and write this formula and substitute all of these in this formula. Okay, then after substitution we have to take the Laplace transform on both of sides. Then here we have 3 terms. Okay, so what we'll do is we'll find the Laplace transform separately. The first term is Laplace transform of 2. Okay, that's by using direct formula we'll get. See, in the second term we have along with it u of t minus 1. So here what we'll do is we'll write Laplace transform of t square by 2 minus 2 into u of t minus 1. Now to find this we have to consider this as f of t minus 1. It's actually f of t minus 1. Okay, why t minus 1? Why t minus 1? Because it's u of t minus 1. Okay, so f of t minus 1, this will be equal to f of t minus 1. Now after writing f of t minus 1 is as t square by 2 minus 2, we will substitute t by t plus 1 because we need f of t here. Okay, so we'll be substituting t plus 1 here and here as well. So after the substitution we'll have f of t as t plus 1 whole square by 2 minus 2. Now finding the Laplace transform, and we'll separate these terms by expanding it and finding the Laplace transform of each of these. Similarly the third term also we'll do in the same way. We have t minus pi by 2 here, so this will be f of t minus pi by 2. F of t minus pi by 2 will be cos t minus t square by 2. Now replace t by t plus pi by 2. and then we'll expand it and find the Laplace transform of each of these separately. Now after finding all of the three terms, we will just add it up to get the final answer. Coming to module 2, the first question is to find the Fourier series of the given function. The first thing is you need to find if the function is even or an odd function. How you will do that? See, f of x, f of x is x here, and f of minus x is 2 here. Okay, now these both are not equal, right? So that's not an even function. It's not even an odd function because x is not equal to minus of this one, so it's not an odd function also. So it's neither even nor odd. In that case we have to find a naught, a n and b n. Okay, so the formula for a naught is this one, and instead of f of x we will be substituting 2 and x according to the limits. Okay, so we'll be taking two integrals, one from minus 2 to 0 and from 0 to 2, and in these two integrals this value will be substituted and we'll simplify it to get a naught. In the same way we'll do for a n also. We'll separate the integrals, and the extra thing here is cos n pi x by 2, and after you expand it and apply the limits you will get a n here. In the same way you have to find b n also, just instead of cos you have sine here. Doing the same way, after we get b n also, what we have to write, f of x as this is the standard formula, and instead of a naught, a n and b n you have to substitute the answers which you got above, and then you will get the final answer. In the next question we have been asked to find out the half range cosine series. Okay, this is the formula for cosine series, and we'll have a naught and a n, will not have b n, and we'll just substitute what is f of x, which is x plus 1, and find the integral for a n as well as a naught, and after doing that we'll substitute that in the standard equation, and this is your final answer. Similarly we have the next question, and you have to find the Fourier series of this function in the period 0 to 2 pi. See, when the limit is given as 0 to 2 pi, how can you check if it's an even or odd function? You have to check for f of 2 pi minus x and f of x. Okay, now f of x is x square, f of 2 pi minus x is 2 pi minus x whole square, so it's neither even nor odd. So we have to find a naught, a n and b n. So we'll be using that same formula and finding a naught, then similarly a n also and b n also. Okay, after doing that we'll substitute back in this standard formula, and this is the final answer. In the next question we have been asked to compute the first two harmonics of the Fourier series, and this table is given which has the x and y values. So for this question, since we have been asked to find the first two harmonics, you have to write y cos x, y sin x and y cos 2x, y sin 2x. Okay, we'll be writing that x and y values here, and we'll be finding y cos x, y sin x, and similarly y cos 2x and y sin 2x. Then we'll be adding each of these. Okay, these all column values here. After doing that we will be using these values in these equations. Okay, b1, b2 and a2. Since we have been asked to find first two harmonics, we have to find a2 and b2 also. So this is nothing but, see, for example, this column is of y, right? So if we add all of this, this is summation of y. So in this formula that will be applied. Similarly y cos x, this is the summation of y cos x, this will be applied in a1 here. Okay, and in that same way n is nothing but how many terms are there which you have used. This is 6 terms, right? So n will be 6, and by using these values we will find the a and b values, and to find the first harmonics it's a1 cos x plus b1 sin x. For the second harmonics is it's a2 cos 2x plus b2 sin 2x. Substituting the values of a1 and b1, and here a2 and b2. Okay, and these are the first two harmonics. In the next question we have been asked to find the half range sine series. Okay, before we did was cosine series, this is sine series. In this we just have to find bn. Okay, in the interval which is given 0 to 1. Now for this question, first we will write f of x, and remember one thing, when we are asked to find the half range, we have to write the formula and directly find it. Okay, we need not check for if it's even or odd function. Okay, so this is the formula. Instead of f of x, we will be writing e of x, and we'll be just expanding it using this formula. Okay, it should not be expanded using parts, it will be a very lengthy process. This is the formula, and by using this formula we'll be substituting the values of a and b, and you'll be getting b of n here. Okay, and after that, for half range sine series, this is the standard formula, and in the place of b of n we'll write this, what we got the answer here, and sin n pi x should be written here. I forgot to write. Okay, this sin n pi x will be written here, and that's your final answer. In the next question, we have been asked to obtain the Fourier series of the function which is given in the interval minus pi to pi. You can check for yourself, the function is even. When we substitute the value of minus x, we will be getting the same value if we substitute for x also. So this function is even, and we have to find a naught and a n. We need not find b n. Now by using this formula, we will be substituting the values and the limits to get a naught. Okay, similarly a n also will get, and finally we will write the equation. This is the standard equation, and in the place of a naught and a n, will be substituting the values which we got, and this is the final answer. Coming to module 3, the first question is to find the infinite Fourier transform of e power minus mod x. This is the standard formula for infinite Fourier transform, and in the place of f of x we will be substituting the e power mod x. Now we have to separate the integral limits here. Why? Because mod x is not same for the whole limit. Okay, so when x is less than 0, it's minus x, and when x is greater than 0, it's x. So since we have e power minus mod x, we will be using this mod x values in the place of e power, and we will be getting these two values. Now after we got these two values, we have to separate the integral as which is less than 0 and greater than 0, and in the place of each of those we will be substituting the f of x values. Okay, so the first integral is minus infinity to 0. In that case, f of x is e power x, and similarly from 0 to infinity, f of x is e power minus x. Now it's just a simplification part, and you will get the final answer. Okay, in the next question, we have been asked to find the Fourier cosine transform of this function. So this is the standard formula for Fourier cosine transform, and f of x is given to be this, and when we substitute f of x in this place and find the integral by separating the limits for this term cos x and for this term cos x, we will be getting two integrals, and solving each of them separately by using the formula of e of x, we will be getting these two terms here. See these two terms, and we have to substitute the limits here. Okay, after we substitute the limits, we will get the final answer. In the next question, we have been asked to solve the given equation, and we have been given u naught and u1. Firstly, we will write this given equation and what is given to us, the values, and for each of this, there is an expansion. Okay, un plus 2, un plus 1, and un. Okay, these three expansions, and we will be taking u of z as common and shifting all of the other things to the right hand side. Okay, so we will be getting u of z here. That's the step 1. In step 2, we will be taking the inverse of u of z. First step is to take this z in the denominator, and then by using the partial fraction method, we will be finding this ABC values, and then the normal substitution back, we will be substituting back the values of A, B, and C which we got here, and then find the z inverse of this the three terms. These are the standard terms. These have the standard z transforms. We will be substituting that in this place and simplifying the equation, and we will be getting this final answer here. Coming to the next question, we have two parts here. We have to find the infinite transform, and we have to evaluate this term here. Okay, so first we will be finding the infinite Fourier transform of this function. Now observe here carefully, f of x is defined as 1 when mod x is less than or equal to a, 0 if mod x is greater than a. See, mod x means it does not matter if it's negative or positive. If that value is greater than a, I mean if it's greater than a, then it will be 0, or if it's less than a, it will be 1. Okay, so in these two cases, mod x is greater than a, so it will be 0. We will be just considering the middle case, okay, minus a to a. So this limit will be from minus infinity to infinity. Since the terms here are 0, the only limit which is getting considered is the middle one. So we will be taking the limit as minus a to a, and in that limit f of x is 1. Okay, it's given in the question, 1 when mod x is less than a, and we will be finding the integral and substituting the values, and we will get 2 by s sin a s. Now our next step is to evaluate the given term. Okay, see here, this is the term which we have to evaluate. Okay, observe here, it's sin x by x, but here we have 2 by s sin a s. So the difference between both of those is 2 and a. So what we will be doing is we will be taking the value of x as 0 and a as 1. Why you are taking x as 0? Because we need to remove this term e power minus isx from here. Okay, so if you take x as 0, it will be e power 0, which is 1. So this is the standard formula of inverse transform, inverse Fourier transform, and in the place of f of s, see, f of s we got here, right? See, this is the Fourier transform which we got, 2 by s sin a s, and in the place of this we will be substituting 2 by s sin a s. Then after taking x as 0 and a as 1, we will be getting the desired we will be getting the term which we had been asked in the question, which is 2 by s sin s, 2 by s sin s ds, and it's an even function because see, sin s is odd function and s is also odd function. So odd by odd is even function. So when we have even function, we can write this limit from minus infinity to infinity as 2 times that of 0 to infinity. Okay, so we will be changing s to x, because in the question they have been asked as sin x, right, sin x by x. So instead of s we will be writing x here, and dx instead of ds, and see here, when we take x as 0, what is f of x? See, according to the question, when we take x as 0, f of x will be 1, right, because 0 is less than or equal to a, it lies here. So f of x will be 1. So that's what we are writing here, f of 0 is 1. So 1 is equal to this term here, and keeping this term aside, we will be shifting all other terms to the left hand side. So we will be getting this term as pi by 2, equivalent to pi by 2, and this is the final answer. The next question is about the derivation. We have to derive the formula of cos h n theta and sin h n theta. For this question, you need to know what is cos h n theta in terms of E. Okay, in the formula list, I have mentioned all of these formulas of cos h n theta, sin h n theta, and in terms of E. Okay, you can refer to that. Now, instead of cos h n theta, we will be substituting the E terms. Okay, since we have the formula of z transform in the terms of E, we will be using that to simplify it, and then see, you will reach this step here. In this step, you have to multiply 2 and divide by 2. Why? Because then you will be getting the standard formula of cos h theta. Okay, the formula of cos h theta is e power theta plus e power minus theta divided by 2. So you have the 2 in the numerator also, so we will be taking 2 cos h theta, and similarly in the denominator also you will be doing the same. So we will get cos h theta in the denominator as well, and multiply it inside and cancel this 2 from the numerator and denominator, and this is your final answer. The same thing we will be doing for sin also. This is the formula of sin h n theta. We will be using that to find the z transform, and multiplying and dividing by 2 from the numerator and denominator, we will be getting the final answer, which is z sin h theta divided by z square minus 2z cos h theta plus 1. Okay, denominator is same for both cos h n theta and sin h n theta, only the numerator changes. Okay, In the next question we have been asked to find the inverse Z transform of this function, and in this function we have to use the partial fraction method. Okay. Now consider the given term as u of z, and what is u of z by z? Take the z common from numerator and take it in the denominator of u of z, and we will be remaining with this. Okay. Now separating these terms we will be getting in the partial fraction method as this thing. See, one thing you need to observe is whenever you get the terms as z minus 2 whole square, okay, if you get the square, what you have to do, first you have to write z minus 2, then z minus 2 whole square. And when you will be writing square, right, what you have to write, if it is z minus a, see it's of the form z minus a whole square. Okay, the standard formula, if you look at the list, when you get z minus a whole square, the numerator should be az. Okay, now in this case a is 2, so we will be multiplying c by 2. Okay, here we are just finding what is the value of a, b and c and substituting them back in the main equation and finding the z transform. Okay, z inverse, we have got this in the standard form. Now we can find the z inverse by using the standard formulas, and this is the final answer which we get. Coming to module 4, we have been asked to solve the given equation by using Taylor series. Let's see how to do that. For Taylor series we have two steps. First we will be given with dy by dx, we will be taking it as y1 and finding y1 of 0. Okay, means substituting the values of x0 and y0. Okay, so we will be getting minus 1. Then we will be differentiating y1 to get y2, and in the same way we will be differentiating y2 to get y3. In each case we will be finding y2 of 0, y3 of 0 by substituting the values of y1 or x0 where it's required. Okay, so we'll get till y4. Okay, and after that it depends on the question what they ask. If they ask to find up to 4 terms, you have to find till y4. Okay, then after that this is the formula for Taylor series, and in this formula we'll be substituting all the values which we got, and then after the substitution we will be remaining with x terms in the final equation. Now in the question they have asked us to find, see here they have asked us to find the value of y of 1.1, so x is 1.1. So instead of x we will be writing as 1.1 and calculating the value. In the next question we have to use RK method to solve the given equation. For RK method we will be writing what is given like x0, y0 and h, and finding what is f0, and then we will be writing this table here. Okay, in this table the first column is x, then y and f, which the function which is given, and k is h into f. We will get k1 to k4 values, and k is nothing but we have to substitute the values of k1 till k4 in this equation. We will be getting what is k here. Okay, now after getting k you have to find what is y. Y is nothing but y0 plus k. Y0 is given in the question, and you have to add with k which we got here. In this question we have to find the value of y of 0.4, and the given equation is this by using Milner's method. Okay, see these are the values which we have, and this is nothing but x0, x1, x2, x3. Okay, similarly y0, y1, y2, y3, and this is the equation, and by using these equations we will be finding what is f0, f1, f2 and f3. Okay, and we will be using these values in this equation, and we will be getting y4p. Now when we get y4p we have to find y of 4.4, right? So x4 is 4.4 and y4 which you got here. By using these two values we will find what is f4, and when we get what is f4 we will be using this formula of y4c, and in this formula we need f4 here. We will be using this value here and calculating the final answer. Coming to the next question, we have to find the value of y of 0.4 by using Euler's method. Okay, first we will write what is given in the question, and next we have to find f0. After we get f0 we will be using that value to find what is y1. Okay, see after getting f0 we will be finding what is y1, y0 plus hf0. After getting y1 and f0 we will be using these two values here. Okay, in this table, and this is nothing but we will get this f1 value here. By using this we will get a new y1 value here. This will be using here to find the next value. Okay, like this 3 times we will do, and after doing that we have y of 0.2 as 1.19724. But in the question C we have been asked to find the value of y of 0.4, but we got y of 0.2. So in this case what we have to do is we have to consider 0.2 as x naught and this as y naught, and then we have to repeat this step again to find value of y of 0.4. okay, now the repeating this same step again, what we'll get is, so in the next step what we will do is we will be considering x naught as 0.2 and y naught as this. okay, when we consider x naught as 0.2, what we will get, 0.2 plus h means x naught plus h, right? So we'll be getting 0.4. so the difference here is we'll be writing 0.4 here instead of 0.2, and y naught is this value. See, before what was y naught? This one, right? So instead of 1 we will be using 1.19, this value. okay, when we use this value we will get a new y1 value. okay, and using that value we'll find the remaining terms. okay, so the same process we have to repeat, and 3 times when you repeat, the final answer you will get here, and that is y of 0.4. while scanning the pages, some mistake happened because this answer is not of that question. So anyway, I hope you got the thing right, how to find y of 0.4. We have been given with this equation and this table. Now similar to the previous question, we have to find f naught, f1, f2, f3. okay, see f naught, how you will find, this is x naught and y naught. so in the function 2 minus y square by 5x, so instead of y and x we will be using these x naught and y naught values. okay, we will be getting one answer, that is f naught. so for f1 we will be using x1 and y1 values, this one, these two values. so for f2 and f3, when we get till f3 we will be using this formula of y4p. okay, when we get the value of what is y4p, okay, this y4p will be used to calculate f4. okay, by substituting the value of x and y, which is x is 4.4 and y which we got here. By doing that we will be getting f4 value, and using that value we will be finding y4c. okay, and that's it, and this is the final answer. Coming to module 5, the first question is to solve by RK method the given equation, find the value of y when x is 0.2. okay, similar to the previous module we have to use the same thing, we have to write the k value here. okay, but in this question we have z also, right? so we will be using a separate term for z here. okay, just as we used k for y here, we will be using g for z here. okay, and by using these two values, and we will be using these values to find what is y. okay, similarly for z also we will be using the L values which we got at the last column here. okay, by using these values you will be finding what is z at 0.2. The next question, they have asked to derive the Euler's equation in the standard form. You will be using these three values in this equation, f of x comma y dash. Instead of y you will be writing this one, instead of y dash you will be writing this one, and then you will be differentiating both sides with respect to eta, with respect to epsilon. okay, and then since x is constant here, this will become 0, and moving on further we will be separating both of these terms, and then in this case we will be solving the integral by parts. okay, in this case you will get eta of x as 0 because eta of x2 is equal to eta of x1. so when you apply the limits you will get here as 0, so you will be remaining with this term here. Now in this term you have eta of x as common, and that's according to the standard formula this is equal to 0. so therefore what's inside the integral, that will be equal to 0, and this is the standard form of Euler's equation. Coming to the next question, this is the numerical part. We have to find the extremal of the functional which is given here. Our first step is to take the f of x comma y dash, and then find what is del f by del y and del f by del y dash. okay, after getting these terms we will be using these two values in the standard equation. okay, then after substitution what we will do is we will be separating these two terms and finding the integral here. See, first you have to take this as separately in RHS and shift all of this in the other side. Okay, so you'll be remaining with this term here, and then shift this dx here and then integrate both sides. So when you integrate, this will be cancelled and this term will be remaining here, and when you integrate with this, you will get the terms here and with and a constant here, and then you have to find see, y dash is nothing but dy by dx, right? So you'll be shifting dx on the other side and keeping y here. So when you integrate again, you'll be remaining with y, and that's your final answer. Coming to the next question, we have to find the value of y of 0.4 by using these given values. So first we will be noting down what is given, and by using these values we will be filling this table. Okay, this is our x, y, z values which are given here, and f is the same as z. This is always same, these two terms, and the final one is g. See how to find g from this equation, which will be d square y by dx square, that is g, and this is z, dy by dx. Okay, so by using that we will be finding the g values and using these all values to find what is f4. Okay, by using these two formulas. Then after getting f4, you have to find out you have to apply these values in y4c and z4c, and these are the final answers. In the next question, we have to find the extremal of the functional, and this is a bit different one because the limits have been specified here and the values have been given. So we can't leave the final answer in terms of c1 and c2. We have to find what is c1 and c2. Initially we'll be doing the same thing, writing f of x, y and y dash, and then finding what is del f by del y and del f by del y dash. We'll be using these two values in the standard equation, and on simplification we will get y double dash plus y is equal to sin x. Okay, see in this case this is a different type of extremal question, because in this case you will be getting y double dash here. Okay, so if you get y double dash in any case, you have to not use the previous method which you had solved for the previous question. Okay, in this case you have to use this differential equation method. Okay, see yc, if you get d square plus 1, see d square plus 1 is the differential equation. So what is d here? D is plus or minus root of minus 1. Okay, that's nothing but plus or minus I. When you get the roots as plus or minus I, the solution is c1 cos x plus c2 sin x. Now after finding yc, you have to find yp. Yp is nothing but keep this y here, shift this in the denominator, it will be d square plus 1. Now when you get the solution in this form, what you have to do is, see sin x is here, right? When sin x is in the numerator, you have to replace d square by minus a square. A is nothing but it's of the form sin ax. We have been given sin x, right? So a is 1. Comparing these both, we'll get a as 1. So we'll be replacing d square by minus 1. So when we replace that, we'll be getting denominator as 0. Okay, to avoid that, what we can do is, we'll be differentiating the denominator. So we'll get 2d, and we'll be multiplying the numerator with x. Okay, so what we get is x sin x by 2d. Now take this x and 2 as separate and find this sin x by d. What is sin x by d? See, d means differentiation. 1 by d, the reverse of differentiation is integration. Okay, so it's of this form. It can be written as 1 by d into sin x. 1 by d is nothing but integral. So you have to find the integral of sin x. Okay, so integral of sin x is minus cos x. So that's what I have written here, minus 1 by 2 cos x. Okay, this is minus x by 2 cos x. Okay, x will be here, so minus x by 2 cos x. Now after that we will be adding yc and yp to get the final answer. Okay, instead of x we will be using these values 0 and pi by 2, and in the place of y we will be using these two values 0 and 1. So after doing that, we will be getting y of 0 is 0. Here we will be getting as c1 minus 0. Okay, it's actually 0 because x is here, right? So c1 will be 0, and similarly we will find c2 also, and we will be getting the final answer here. In the next question, you have to write the proof for the geodiscs of a plane surface which are straight lines. For this derivation, we will be starting with the arc length. This formula we will write here, and as usual we will be writing f of x comma y dash what we get here, that will be writing here, and finding del f by del y and del f by del y dash. Now by using these two values, we will be finding the standard equation solution. Okay, so this is just integration part, and you have to do in this same way to get the desired answer. Okay, so after you get till here, y dash has m. See here, if y dash is equal to m, dy by dx is m. Okay, so when you shift this dx to the other side and integrate, you will get as integral dy is equal to integral m dx. So you can write as y is equal to mx plus c, and the equation y is equal to mx plus c is nothing but the equation of the straight line.